Hey students, this is your Professor O'Million-Chuck, and today I want to go over some more derivation rules, specifically the direct rules of inference. Right, so my big word of advice to you when it comes to doing derivations is to keep calm and follow the rules. Right? Following the rules is how you do derivations. I know that sounds really simple and not very helpful, but it actually is very true. So just try to keep that in mind, all right? Right, just to kind of remember what derivations are. Remember, they are ordered sets of formulas. All right, some of the formulas may be given as premises, others are of assumptions that we make, and then others are derived by a rule of inference. Right, the last line in the set is what we ultimately want to derive, which is the conclusion. Now, if you remember, I introduced you to kind of this picture, right? And these are all throughout the textbook that you're going to be reading, and these are kind of the pictorial representations of the rules of inference. All right, so remember, just the way to read these is that you kind of have to think of the line as dividing the inputs from the outputs. So in this rule, what's above the line specifies the formulas that you need, right, to appear on any of the lines of a derivation before the rule can be applied. All right, so, remember P and Q, those can stand for anything, right? But the idea is that you got to have P arrow Q and a P, and then you can write down what's below the line. That's the output line, and you can write down Q. Right, so you can never eliminate for the antecedent in this rule. You can only eliminate for the consequence, right? And that is arrow E, okay? I'm sorry, which is conditional elimination. Right, so basically, the idea is this: you have to find a conditional on one line, and then the conditional is antecedent on another line. So you got to find two things. Then you can write down the conditional's consequent on a subsequent line and cite the two lines with arrow E in the margin. Okay, this is what's called a direct rule of inference. Right? A direct rule of inference is one that does not require you to make any assumptions at all. Right? So we did see a rule in the last lecture where we were making assumptions and starting subderivations. Okay, those are called indirect rules of inference. All right, and those we only have two of them in our system. So conditional introduction is like that, right? And here it is. Okay, so this is making you make an assumption. So you start a subderivation, you assume the antecedent, you deduce Q. Stop the subderivation, and then you can write down P arrow Q. All right? And this was an example of that I did in the last class. All right? So, we're not going to be talking about those today, right? And so what we're actually going to go over, right, is the direct rules of inference where we don't have to make any assumptions at all. And so let's take a look at those. There's a bunch of different ones besides conditional elimination. And the natural place to start is actually with biconditional elimination. Biconditional elimination is just like conditional elimination, except that you can actually go both ways. All right, so you're allowed to go both ways. So here's the deal, all right? So suppose you got P double arrow Q on a line, and you have P on a different line. Then you can write down Q on a subsequent line. Or similarly, right, you have P double arrow Q on a line and you have Q on a different line, then you can write down P on a subsequent line. Okay, so either way, you have to cite two and only two lines and write double arrow E in the margin. Okay, so here's an example. Okay, so here we have FA double arrow GA, and I got GA. All right, I can derive FA just like so. And if I wanted to, right, I could use FA and line 1 right there and write down GA again. Okay, notice how I'm citing two lines, so don't forget that. Don't just cite one line and eliminate, okay? That's wrong. You have to cite two lines, okay? So just think of it this way. If you want the GA, if you want the FA here, well, you got GA here, and that can get you then to FA. Okay, so those are the two kind of individual components that get you the FA. Now you can get GA again, right? Because now you got FA, right, on line 3, and on line 1, this is saying, hey, if you got FA, you can get GA, and so that's why you're writing that down there, setting lines 1 and 3. Right? So the picture that you should become familiar with, and you really should be memorizing all these rules of inference, all right? All right, I can't stress this enough. If you don't know the rules, then you can't do the problems. It's just that simple, right? So you have to know these backwards and forwards. You really, really do. Right, so it takes 2 lines as input. So if it's saying 2 lines, then you got to cite those 2 lines to write down what it is that you want in the margin. Okay, so that's biconditional elimination. Conjunction elimination. All right, so suppose you got a conjunction on a line, P and Q. All right, and let's suppose that it's true. Right, well then, since conjunctions, both sides of it have to be true in order for the whole thing to be true, then we can say that P as well as Q is true. Right, so here's the deal. If you have a conjunction P and Q on a line, then you can write either P on a subsequent line or you can write Q on a subsequent line. Then you want to cite the single line that the conjunction was on and write ampersand elimination in the margin. Okay, so I want to drive GA. All right, so here's the thing you have to remember about this. So if GA is my target, I see GA right here. I can't just grab it and write that down on line 2 and write conjunction elimination. That won't work. Because the conjunction that is on line 1 is HA, right, and then this conjunction here. So I got to eliminate this thing first. But that's easy to do. I just want to work my way in. So what I'm going to do is I'm going to lop off the HA, cite line 1, just like that. And what I've eliminated is this part. Okay, I've eliminated that part. Now I can get the GA. I can extract that because now that is a conjunction and then I can eliminate. Right? I can get rid of the FA. And now I write GA. And notice I'm only citing 1 line because that's the line that conjunction is on. Right? Here is the picture that you should memorize, right? That's ampersand E. Notice how you're only citing a single line. That's the line that the conjunction is on, and then you're taking 1 part out of it. So in this case, it's P, and in this case, it's Q. Let's talk about negation elimination. Right? This is based on the idea that double negatives are redundant. Okay, so suppose that not P is false. Well, then P is true. So if you have not P on a line, well then you can write P on a subsequent line. All right? Then you cite the line on which not P was, and then write not or tilde E in the margin. Okay, so it looks like this, right? And then you just write that. Okay? You can only take 2 at a time, so suppose you got like a negation that's got like 4 negations, right? So you have to take 2 at a time. Okay. Here's the picture you should memorize. Negation elimination just looks like so. You have to have a not P on a line, then you can write P. And you know, this rule gets overlooked, right? It's really simple, and I'll explain why when we get into later lectures. But just be mindful of it. So it's something you need to memorize. All right, let's talk about disjunction elimination. Okay. This makes use of the idea that when a disjunction's disjuncts, so both sides of the disjunction, if they both entail the same thing, well then you can write down whatever it is that they entail. All right, so let me give you an example. Right, the Democrats or the Republicans will win the next election. Either way, we're hosed. Okay, or either way, we won't be represented. Maybe that's a more, you know, that's a less, you know, it's a less mean way of putting it. All right. Okay, so therefore we're hosed, right? Therefore we won't be represented. Okay, that's an argument form. So here's like premise 1. Here's the disjunction. Okay, there's the or clause, and then here's the kind of either way. Well, this is where we're going to end up. And so therefore we're hosed. All right, so this is an argument form. Okay, and so the way it works, it goes like this, right? With respect to derivations, if you have P or Q on a line, P arrow R on another line, and Q arrow R on still another line, then you can write R on a subsequent line. Okay, So here's the thing, look, P and R and Q and R, they don't actually have to be different. They could be the same, okay? But the thing is that the R has to be the same, all right? So the P has to lead to an R, and the Q has to lead to the R, all right? And so then that way you get rid of this disjunction, and you write down R. This one's kind of tricky, right? But at any rate, what you do is you have to cite 3 lines. You have to cite this formula, and then the line that this formula is on, and the line that this formula is on, and then you can write ring E in the margin. All right, so here you have something that looks like this, right? Here's a pattern. Here you got a disjunction, FA ring GA. Notice that the FA here is the antecedent of a conditional that has HA as the consequent. HA is also the consequent of a conditional where GA is the antecedent and GA is the other disjunct. So what you can do then is write down on line 4 HA, right? And cite lines 1, 2, and 3. Ring elimination. Right, this is basically the toughest direct rule of inference, right? Because it's so demanding, right? It requires you to have 3 different things, right? And so you have to have these 3 things if you're going to eliminate a disjunction, right? Disjunctions are actually really hard to get rid of, right? So keep that in mind. We're going to be visiting this rule a lot, right? Because the idea is if you can master this rule, then all the other ones are easier, all right? So I'm going to kind of spend a lot of time working with disjunction elimination. All right, so those are the elimination rules, all right? There's only 2 kinds of rules that we have. We have elimination rules and we have introduction rules, all right? So elimination rules are those that are getting rid of connectives. Direct introduction rules are those that create connectives, right? And here you don't need to, these are rules that introduce connectives without any assumptions being made, right? So let's look at conjunction introduction, right? Conjunction introduction works like this. If you have P on a line and Q on a different line, then you can take P and Q and stick them together and write P and Q on a subsequent line, right? Or, here's the other thing you have to understand is that order doesn't matter with the rule. You could just as well write Q and P, right? The rule will apply. That's okay, right? Then you cite the 2 and only 2 lines that P and Q are on and write &I in the margin, right? So you need to cite 2 different things. There's 2 different components to a conjunction, and those are the components. They're going to be on different lines, and you'll have to cite those 2 lines. So here's an example. Okay, I don't have a specific target here. I'm just kind of playing around with the rules. So what I'm going to do is I'm going to take lines 2 and 3, and I'm just going to stick them together like so. All right, I could have put GA first and FA second. It wouldn't have mattered. That would have been fine. Okay, but that's a legitimate use of the rule. I just want you to see that I'm citing the 2 lines, 2 and 3. Okay, and notice that I'm doing &I, right? Because I am introducing the conjunction, right? I'm creating it. I could take lines 1 and 4 and stick them together, like so, right? And that's also a legitimate use of the rule, okay? So the picture that you should commit to memory is this. &I, P on a line, Q on a line, then you can write down P and Q. Or you could write down Q and P, right? I didn't do another one like that. That's okay too, okay? Let's talk about disjunction introduction, right? This is based on the fact that a disjunction is true just if at least one of its disjuncts is true. Okay, so here's the thing, right? If P is true, well then P or Q is true as well. All right, do you see that? You have to understand that disjunctions are weaker statements than just the singular statement. All right, basically like, oh, well, P is true and so is P or Q. Right? You might think it's kind of, why are you adding on this superfluous information? That's a good question. But logically speaking, right, you don't move from a truth to a falsehood here. And so it's a valid rule of inference. Okay? So if you have P on a line, you can write down P or Q on a subsequent line and then cite the single line that P was on. Okay, this is important Because you're like, well, wait a second, where did you get Q from? Don't you have to get Q from another line? And the answer is no, you don't. You can just introduce it as needed. It's a creative project. You just say, okay, well, you know, I want Q, and so I'm going to get Q, and so I'm just going to introduce it off of P. And that's part of the creative project. You don't pull Q from anywhere else, right? It's not like conjunctions where you have to have the two components and stick them together. You actually just introduce it. Again, order does not really matter, okay? You could just as well write Q or P, right? So if you have P on a line, you could write Q or P. All right, so let's see it in action here, right? Okay, look at that monstrosity. This is what I have to derive. This is the target. Okay, and it's like, gosh, that's how am I going to get that? And this is my premise. I just have FA, and that's pretty weak, right? But notice the way the target is structured here. I got FA right here, and FA is inside of a disjunction, which is part of a further larger disjunction, which is right here. So what I'm going to do is I'm going to introduce this first piece of it, okay? And so what I'll do is I'll introduce not GA. And you'll be like, wait a second, Professor O, where did you get this not GA from? Well, I introduced it. Okay, I didn't get it from anywhere. This is what the rule allows me to do. It's kind of magical, right? Let's say, okay, so I need that piece. All right, I'll just introduce it. Okay, that's fine. Because FA is true. I'm assuming FA is true. So this is going to be true. Okay? Now, off of this piece, right, I can introduce this whole other piece. Yes, that whole other piece just gets added on. And notice how I go this way now, right? And you'll be like, well, wait, where did you get all that? Well, I just introduced it, okay? So this is a very powerful rule. I can create whatever it is that I need, right? So long as I have a piece of what I need in my premises, and I do, okay? And that's just from line 2, right? So this whole thing just gets introduced. Okay, here's the picture that you should memorize. Ring I. What's that mean? Well, if you have P on a line, then you can write P ring Q, or you could write Q ring P. Okay, let's talk about biconditional introduction, right? A biconditional, right, remember, is just a conjunction of conditionals, right? So here's the thing, right? Think of it this way, is that suppose that you had P arrow Q on a line and Q arrow P on a different line. Okay, so what's happening here is you have P being an antecedent and Q being a consequent in one thing. And then the other conditional is that Q is the antecedent and P is the consequent. If you have that kind of pattern, right, you have those on two different lines, then you can write down P double arrow Q on a subsequent line. All right? Then you cite the two and only two lines, so whatever line this is on and whatever line that's on, you justify it and you write double arrow I in the margin. Okay, so there you have those two things, all right? And then you can write FA double arrow GA, okay? Okay, so here is the picture that you should memorize. This is double arrow I. You need to have a P arrow Q and a Q arrow P, and then you can write down the double arrow, P double arrow Q. All right, so let's get into some practice problems here. I want to derive this thing. All right, so what you need to do, okay, what you need to do is figure out what the main connective is of your target, right? So look, if it's atomic, well, then you don't have a main connective. But here I do have a main connective, right? And it is right there, right? It is a conjunction. Now, on my last line, that tells me something. I'm going to be using conjunction introduction, and I'm going to be combining KBB, which I have in premise 3 there, with this whole thing here. Now, the problem is I don't know where this is, okay? I don't have that as a premise anywhere, but I think I can create that because I notice that it is also a conjunction, and the two components of the conjunction are in my premises. See that? So what I'm going to do is I'm going to create that thing, right? I'm going to get that thing, and I'm going to make it. Boom, just like that. I'm going to use 1 and 2, and I'm going to use ampersand introduction. Okay, ampersand introduction. Okay, And now what I'm going to do is I'm going to then combine line 4 with line 3. All right. See that? Line 4 and line 3. And now I'm going to be able to get my target. Right? And I got exactly that. Right? I got exactly that. Okay? All right. So that process, right, what you're going to be doing basically is trying to figure out how you can get your target. And you kind of have to work backwards from your target, and there'll be a fuller lecture on how to do this, right? But I want you to get used to being able to see and deploy the rules, all right? And work through these practice problems, okay? Just work through that, and you know, and do the best you can. I think I need to make an answer sheet for this because I don't have one. All right. Usually, what I end up doing is I kind of work with these in the classroom, but since y'all are online, I won't be able to do that. Okay. So anyway, that is the lecture. Now, there is a homework that's due that's related to the direct rules of inference. So let's get out of this and look at homework 7. All right. Let's take a look at homework 7. Homework 7 is not as complicated as the practice problems, actually. Okay, basically what you're going to be doing is you're going to be filling in the missing well-formed formulas and the justifications in each derivation below. All right? So that's what you're going to be doing. Okay? So here's the thing. What you got to know is you got to know the rules really well. Okay? You got to know the rules. Okay? And so basically what you have to do is figure out how it is. Okay, how did we get this LA? Okay? How did we get that LA? Now, you might think you got it from line 2 with arrow elimination, but that's not right because you can never eliminate for an antecedent. That never, ever works. Okay? You can't do that. The only thing you could ever eliminate for with arrow elimination is a consequent. So you're not going to be able to get LA from line 2. But if you look at line 1, it's inside of a conjunction, and you have a rule that allows you to eliminate conjunctions using only one line. So right over here, you would write line 1, and that would be conjunction elimination. Okay, and so then you figure, okay, what happens if we use conditional elimination on lines 2 and 3? Well, let's look at lines 2 and 3. Okay, and okay, so you have the antecedent here on line 3, right? And so there, okay, that gives me not FA. Okay, so I can write down not FF, right? And so you go on, so on and so forth, right, through the end. Now, they get progressively more difficult, right? So, you know, please, you know, don't hesitate to ask me any questions about this, how to do this. But what the purpose of this assignment is, right, is to help you get familiar with the rules. Because if you don't know the rules, you won't be able to do these derivations, okay? All right, so that is the lecture for today. Again, if you have questions, just shoot me an email, ask me questions in the discussion section, and I will talk to you later.